So for the various parts of question 4, we're looking at chemical formulas as well as functional groups. And so a lot of times I find the easiest way to approach these problems is to just draw a molecule that contains the correct number of carbons and all of the functional groups. Once you've done that, you can count up the number of hydrogens and see if it matches. If you have too many hydrogens, which will be the most common error, then you have to look for ways to start to remove hydrogens. And the two ways that we most commonly do that are to add either double or triple bonds or rings. So let's see how that works here. So first thing on these questions, you've got to know your functional groups. So we have an alkene, which we know is a carbon-carbon double bond. We have a carbon-carbon triple bond, or an alkyne, and a ketone, which is a carbonyl bonded to two carbons. All right, so I'm going to start. There's our ketone. There's our alkene. And there's an alkyne. And we have 1, 2, 3, 4, 5, 6 carbons. So we'll put a 7th carbon here. Alright, so I have my functional groups. I have 7 carbons. I have an oxygen. How many hydrogens do we have? Well, even though we don't normally do this, let's draw them in. So 3 there, 2 here, 1 here, 1 here, and 1 here. So we have a total of 8 hydrogens. So unfortunately that doesn't work because we're looking for a molecule that has only 6. So the first thing we might decide to do is let's put in an alkene because that'll get rid of 2 hydrogens. But if we read the problem carefully, notice I said I only wanted 1 alkene. So at that point we have to put a ring somewhere in this molecule. And so maybe I'll take this carbon and connect it over here. So now I've got a 5-membered ring with a ketone, still have an alkene, and then I have an alkyne coming off of that. Do I still have all 3 of my functional groups? Yes. Do I still have 7 carbons? Yes, 5 in the ring and 2 on the alkyne. Final question, do I have 6 hydrogens now? There's 1 here, 1 here, 1 here, 2 here, and 1 here for a total of 6 hydrogens. All right, we're going to do the same thing in part B. So again, I'm just going to start by drawing each functional group and connecting them. So carboxylic acid, we need an ester, an ether, and a tertiary amine. Alright, but as we can see, I haven't come close to using all of my carbons. So far we've used 1, 2, 3, 4, 5, 6, 7, 8. We've got 4 more carbons to add in. So for now, I'll just put them over there. So now we have all of our functional groups. We've accounted for our nitrogen. Do we have 5 oxygens? We've got 2 in the acid, 2 in the ester, and 1 for the ether, so we've used all 5 oxygens. What about hydrogens? Well, let's count them. So there's 1 here, 2, 3, 4, 5, 6, 7, 8, 9. This gets us 12, 14, 16, 18, 20, 23. So it looks like we've got a problem because we have 8 hydrogens too many. And that's a lot to get rid of. But notice in this problem I didn't limit you on what you could use. So if we put in an alkyne here, we've eliminated 4 hydrogens. If we put in a second alkyne, we've eliminated 4 more hydrogens. We've eliminated the 8 hydrogens, and we have a structure that fits our criteria. Now, maybe a better way to go about this problem, if we have that many hydrogens over, that's usually a very safe sign of an aromatic ring. And so now instead, what if I do it this way? So I'm just going to draw an aromatic ring and place all 4 functional groups on it. Does that also work? So we have 12 carbons. We've got all of our oxygens and our nitrogen. And how many hydrogens do we have now? 1, 2, 3, 4, 5. Here's 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. So that also works. So 2 very, very different structures that both fit the formula that we're given. Which one's correct? Well, they both fit the conditions that I gave in the problem, so which ones are correct? Both of them are correct. And there's many, many other structures that we could draw which would also work. Alright, part C, C4H6O2 contains an ether but no pi bonds. So again, we can start out nice and simple like that. But we'll find this has 10 hydrogens if we count them. And so we just need to do things to get rid of, and we could very easily, because the problem actually specifies no pi bond, so we can't put in a double or triple bond. So the only way around that is to do something like that and put in 2 rings. Remember, each time we add a ring, each time we add a pi bond, that gets rid of 2 hydrogens.